All right, so let's get going on today's class. So first thing I wanted to talk about today is the next social media professional development assignment number 4. And what we're going to do now is we're getting into the section where you're interacting with your network. But again, we don't have a lot of original content that we can do at this stage of your academic career. You're not running experiments, you're not publishing work, presenting at conferences necessarily. So we're going to continue, though, with our give before you take approach by amplifying the voices of others in our network. So, for example, this is what we did last time, and this is an example of one of the retweets that one of us did. So, again, not a lot that you can necessarily contribute originally at this stage, but you can definitely help others get their messages out and amplify their contributions and help your network out in those ways. So that's going to be the first part of this next step, step number 4. So this time, because it's a little bit of an extended time, because we're not going to be here for Tuesday, it's fall break, we're going to do 4 tweets from any of the psychologists that you follow, and no comments required. But if you do want to comment, like the previous example, make sure that you do read the do's and don'ts of networking online. Make sure that you are being very consistent with the sort of nature of your comments so that you're building that professional presence. And that's what we'll do, retweet any 4 from the psychologists that you follow. And this time we're going to use the hashtag NextGenPsych2019 to identify that particular portion of stage 4. And then the other portion of stage 4 is actually going to be an ask, but it's my ask. And what I'm going to be requesting is a little help in amplifying recruitment efforts for some research that I'm doing. So I'm currently doing a piece of research here with Christopher Crawford. He graduated, he's off at the IU School of Medicine as a research assistant. And we just got IRB approval for this. So we will be sending this out very soon. But be on the lookout for a tweet that is a recruitment tweet. So one of the approved avenues that we have to recruit subjects is through online social media, is through using the network that we have built. So if you can help us spread that, that word out there, and basically just retweet that to help us with subject recruitment, we would very much appreciate that. And then also, this would be a nice way to get involved with the research community portion of your network. So once again, in the future, when you're applying for a job in psychology, when you're applying for grad school in psychology, and you mention things about how you support research, you've always been interested in psychology, and they go through your social media profile, seeing information like this retweeted will be part of the proof that you have that yes, indeed, I am part of that research community. So if you can do that as well for us, and we'll hopefully get that out either later today or tomorrow, so just keep your eyes open for that. And if you can retweet it with the following 2 hashtags, one, research opportunity IUSB, and that'll help me track involvement in this particular part of the bonus opportunity. And then this hashtag, comics on Twitter, we are doing a research on the perception of metaphors in comic book images. And this is the hashtag that is used to identify the comics research community that is on Twitter. So it's just a nice way to let them know that it's out there as well. So if you can do that as well for this next step. And because we're not meeting on Tuesday of next week, this is actually going to be due Monday, October 28th, like 2 weeks from now by midnight. So if you want to participate, want to build your, continue building your social media profile using those 2 steps, please do, and please do it by Monday, October 28th. All right, any questions on that? All right. One last thing that I'll mention is that the request for retweeting of recruitment for our experiment is in no way whatsoever, and I want to be very clear on this, a request for you to participate in the experiment. So as my students, you are actually not allowed to participate in experiments that I run because the IRB considers that to be too potentially coercive. So because you're my students, because I'm grading your research papers at some point, you might feel coercion to participate in research. So that is not allowed by IRB. So this is in no way asking you to click on that Qualtrics link and do the research, right? I want to be very clear about that. However, sharing the recruitment email, amplifying the voices of others, that is allowed through IRB. So that's what we're asking you to do. So I don't want any confusion about that going forward. All right. Methods of experimental psychology. We are now going to hit Chapter 12, Understanding Research Results, Description and Correlation. We are going to be writing the results section very soon in the classes when we come back. We're going to be doing that together as a class. So that's going to be sort of like a group writing assignment that we'll work on as a class. We'll have more details about what exactly goes into that. But I did want to make sure that we cover correlation today because that is a widely used experimental and data collection technique, which is also widely abused. So we'll take a look at 3 things specifically that we need to keep in mind when we're looking at correlations. But before we get to that, just a brief reminder about the library assignment feedback. Then we're going to talk about the peer review assignment that is open and ready to go. And then we'll also talk about what you do after the peer review, after you get your reviews back. And then we'll take a look at correlation coefficients. So we already talked about correlation a little bit, but now we're going to talk about the Pearson product moment coefficient, and specifically how do you interpret that coefficient and mistakes that people make when they interpret that coefficient. And then if we got time, once again, just a little brief thing about inferential statistics to help us get ready for writing that results section. All right, so once again, just for just a real quick recap, if you received a no on any of the criteria in the library assignment for question 2, question 4A, and or question 4B, then you need to resubmit articles for these 3 questions. If you got question number 1 incorrect, go to the Canvas, go to the research paper resources folder, download Roediger and McDermott. If you got question number 3 incorrect, go to that same folder, download Weldon and Bellinger. Those ones are waiting there for you. But these were the ones that were open-ended, where you could choose your own article. So if you got any one of these 3 incorrect, you have to submit a substitute article for those. You need a new one to try to get that approved. So once again, if you received a no on either whether it was recent primary research or reconstructive memory for number 2, or if you received the no anywhere for whether it was highly cited or recent primary research article regarding group memory, you need to submit new articles for that. And just to make it very crystal clear, I did include a library assignment revision complete item in the gradebook, and there were 4 students who are done. You're completely approved. So it was indicated as completed. Everybody else is just blank for the time. And once you get yours approved, I will update yours to be completed. So just in case you have any questions about whether you need to resubmit or you don't need to resubmit, check that gradebook item, the assignment item. Check your feedback that I gave for the library assignment, because it literally has yes and no's for every single one of those criteria, and submit those articles for reapproval. You got 3 attempts to resubmit articles. So if you didn't get it correct, you can try once, you can try a second time, and then you have 1 last attempt. And the due date for this is October 28th. So not this Monday, but next Monday by midnight. So get them in early to take advantage of your 3 opportunities. If you get it in October 28th at 11 p.m., you will have 1 opportunity. You'll take 1 shot because the due date is by midnight at that time. And you do want to make sure that you do get those required articles, because you do need to write your paper based on previous research. And to encourage that, if these articles are not approved, there are heavy penalties in the research paper. You will lose a ton of points for not having 6 approved articles. So don't do that to yourself. Get your articles in if you need to. Most of you missed 1, so all you need to do is find 1 more and resubmit those, and I'll let you know. All right, and then lastly, remember that for the research paper, you must use your approved articles. And again, don't do this to yourself. There's heavy penalties if you don't use your approved articles. And on that note, there is no homework assignment associated with reading the approved articles. So for instance, journal article review number 1 was a homework assignment to kind of guide you through reading the Dease article. Journal article review number 2, homework assignment to guide you through reading Roediger and McDermott. Journal article review number 3, homework assignment to guide you through reading Weldon and Bellinger. But for the other 3 articles, that's assigned as basically your responsibility to read through those. And I would highly recommend set aside some time to do that, because it is very apparent the students that read their other 3 articles compared to the students that might not read or not fully read those 3 articles. And it does affect your research paper. Your introduction will not be as good, your discussion will not be as good. So again, don't do that to yourself. We got plenty of time before the final research paper is due. So make sure that you're scheduling some time to read the articles that you got as part of your library assignment, the approved ones. All right. Speaking of writing the final research paper, your method section has been submitted. So now you are part of a peer review process here to make that method section even better. And what peer review is, it's a procedure that is used by all the higher quality journals in psychology and actually any discipline. They rely on peer review to make sure that the quality of the writing is high. And what it is that you get reviewed, people take another look, and the people are the ones that are at your level. So when I hand my manuscripts in for submission, they send them out to other psychology professors, to other psychology researchers, for them to take a look at it and say, is this any good and should changes be made? So we're going to do the same thing, and your peers, your fellow students, are going to be the ones that are reviewing your work. So this, again, is just to improve the quality of your research, the quality of the writing. That's why we have this peer review process. So the way that it works, it is going to be anonymous. As long as you don't have your name anywhere on your method section draft, nobody will know that it comes from, that it came from you. So you're not going to know who's reviewing your work, and they're not going to know whose work they're reviewing. So it's double blind, and that kind of frees up everybody to be as honest as possible, to be as helpful as possible, without worrying about any sort of retaliation or anything like that. So the peer review process is double anonymous. When you open up your peer reviews that you've been assigned, you're not going to know who's reviewing your work. And when you send your comments back, they're not going to know who reviewed it. So it's going to be completely anonymous. So please be as honest as you need to be. Again, this isn't trying to spare anybody's feelings, or on the flip side, it's not trying to be mean. It's trying to give people the feedback that they need to make their draft better, to improve the quality so that their final research paper is as good as it can be. So the way that this is all working, right now you've submitted your drafts to Turnitin. So Turnitin has this great kind of program where it will take all of the drafts that got sent in, and then what it will do is it will have its pool of peer reviewers, which is everybody that is now registered in Turnitin, and it will take those drafts and it'll assign those drafts randomly to the different peer reviewers. So different students are going to get different drafts, so you're not going to be doing everybody's peer review. I believe we're going to be doing 5 peer reviews per student. And in this way, it's designed so that every single draft will get reviewed by multiple individuals, and that way you get multiple looks for your draft that you submitted. So if you submitted draft number 4 will get 5 people that are taking a look at it. You'll get 5 pieces of feedback, and this will help you understand what it is that you need to do to improve your feedback. Now, if you haven't taken a look at the peer review assignment yet, in Turnitin, this is the link that you click on the methods draft peer mark assignment, and that'll link you to the peer review assignment. And because this is your first research paper, and because this is probably your first peer review assignment, it's highly guided, highly structured. Usually peer reviews are open-ended. Usually if I'm doing a peer review, I will get a paper and the editor will say, basically, what do you think? And that's very open-ended. I don't think we're quite ready for that yet. So we have a guided review process, and it's just a series of yes or no questions. So the way that it'll look is something like this. You'll have the method section that'll pop up that you're reviewing next to on one side of the screen. And then on the other side of the screen and turn it in, you'll see the questions. And the questions are in order of their content and APA questions. The content questions are in the order of the information that you should receive or you should encounter. And you simply just, answer each question and say, yes, did they get it correct, or no, did they get it incorrect? So for example, content, subjects, correct number of total subjects. Did they mention there are 81, I think, subjects in this experiment? So did they get the correct number of total subjects? If they did, then you would indicate yes. If they didn't, you would just write in no. I believe it's open text right now because that's easier to understand when you get the feedback. So all you have to do is write in yes or no. That's the only things that I'm looking for. Correct number of male subjects, yes or no. Correct average age, yes or no. Correct standard deviation for age. So it guides you through what it is that you should be looking for. And the criteria is that if they did it correct, give them a yes. If they did it incorrectly, give them a no. If they're missing the information, that's also a no, right? So if they didn't mention the average age, just indicate no. And you don't even have to mention average age is missing or anything like that. It's just yes or no's for this point. Did they cite Roediger and McDermott, 1995? It's either going to be there or it's not going to be there. So again, give them that yes or no. And then you'll also have APA questions as well. So, was the method section, was the methods heading correctly formatted? Was it center and in bold? Was the subjects heading correctly formatted? So you are going to have to draw on your knowledge of APA that we built up so far. But, again, it's just yes or no. And then for some of them, for the Times New Roman, that'll be apparent. Font size 12 point, as long as it seems close. I don't expect you to download these and measure them with a ruler or anything. But, as long as it seems close to text double spaced, 1-inch margins all around, it'll be obvious if they haven't done that. So, so just go through it. And again, yes or no's, and then once you click submit, that feedback will be sent to the student, again, completely anonymously. And that's how you're going to help each other make sure that your sections, your method draft in this case, are the best that they possibly can be. So that's also the reason why we have 5 people reviewing each individual paper, because I understand and I know that you're learning APA style at this point. So one of you might think that the procedure heading was correctly formatted, when in fact it was incorrectly formatted. 4 of you will probably say, no, it was incorrectly formatted. So you might get that where not everybody agrees. 4 say yes, 1 say no, 3 say yes, 2 say no. And that again helps you get that sort of consensus vote in terms of, did I do this correctly? And at the very least, it'll alert to you that this is something that you need to correct, or at least take a look at to make sure that you're doing it correct. So use the peer review feedback to make your assignment better. So the peer review feedback is going to be due October 28th by midnight. So again, we got some time on that. And just to ease your mind to be as honest as you possibly can, it is way kinder to be honest than to give people a false idea of how they did. So it is way kinder to say, oh, by the way, you did the method section heading incorrect, than to just say, oh yeah, no, that's fine. It's, it's completely correct. So be honest. That's the best way to help each other. And take comfort in the fact that I do not look at the peer reviews when I grade the method section for your method section draft grade. So if you need to give a very negative, no, you got everything wrong review, don't worry that I'm going to take a look at that and say, oh, well, I guess this person is going to get a low grade. I grade these drafts as drafts. So what I'm looking for is kind of a basic attempt at writing a method section rather than a perfect finished version of it. So your peer reviews will have no impact whatsoever on my grading of your method section. In fact, I won't even look at those until I've graded the method section. All right, so again, that's when it's due. And then after the peer review assignment, what do you do after you receive your peer reviews? Well, first thing is, if you feel that the peer review system is being abused, then you need to notify me, the editor, that something weird or something incorrect is going on. So for example, if you see one peer review and it's just all yeses, and every other peer review that you received has said that you've done certain things correct and you've done certain things incorrectly, basically, if you feel that one of your reviewers did not take the time to read your draft and just decided to click yes all the way down and submit that review, that's an abuse of the peer review system. We're working here as a community, helping each other out. We all need to contribute to this. If that's the case, I cannot, in a class even this size, go through every single peer review to check every single peer review. I can check a sample, which I typically do, but people can slip through the cracks. So if you feel that it's been unfair, you need to notify the editor, that is me, to take a look specifically at that peer review. And this is just, this is good career advice. This is how it's handled in the real world. So to just give you an example, when I was submitting to the Journal of Graphic Novels and Comics, I had a reviewer that was being unprofessional. So they were basically asking for all these changes to my manuscript, and when I made those changes and I resubmitted it, they said, well, we want these new changes now. And I just knew if I made those changes, they would say to themselves, well, I want these new changes. They were trying to block my publication. It was clear that they had an agenda and they were trying to block my publication. So what I did is I emailed the editor and I said I was wondering if I could discuss the latest comments with you. In particular, I'm not sure how to proceed regarding the comments made by reviewer number 1. Can we have a phone call or could we discuss it via email? And her response was basically that in not so many words, reviewer 1 was out of line, and just take a look at what reviewer said and make a couple of changes here, and then if you have any other concerns to contact her. So that's what you do if you feel you're being treated unfairly. So if you feel once you get your reviews back that somebody didn't take the time or didn't put in the effort, let me know. Just send me a message via Canvas Messages and just say, can you take a look at one of my reviews? And I'll be more than happy to do that. And then I'll handle that situation to make sure that they participate fully in the next review process. So that's the first thing to do after the peer review. Second thing you want to do is you want to use the feedback from your peer review. That's why we're doing these peer reviews. So take a look at your feedback and you will see things like, did I do this correctly? 5 yeses. Awesome. Did I do this correctly? 5 no's. Oh, I better go back and check that. Oh, I'm missing the age of the subjects. Oh, I forgot to mention, that they were here at IUSB. Oh, I didn't do this bold flush left like I was supposed to. So use it to improve your method section. And what we're going to do is we're going to, for your final paper, have this peer review summary. And this is going to be where you track the changes that you made to your draft in response to your responses to the reviewers. So I will upload these Word documents very soon. And basically what it will do is it'll have every single question that was asked on these peer review guided questions. And then what I would like you to do is in the Word document, just indicate how many yeses you had and then indicate the changes that the responses made. So if you had 5 yeses, the changes could be, none needed, not applicable. If you had 0 yeses, you might say, correct number of female subjects, 0 yeses, changed it from 2 to 81, whatever it might have been. So this is where you kind of indicate the changes that you made in your draft, and that again is something that we do in professional publications. When I give back my my redone manuscript, I literally say, in response to point 1 from reviewer number 2, I changed this line, to this line. In response to, comment number 2, I included the reference for this. In response to comment number 3, so you indicate what changes you've done as part of your revision process. And then these documents will be available in Canvas, and then that will be due with your research paper. So once you finally hand in your final research paper, you will also hand in these peer review response summaries. So basically, as you're going through revising your drafts, when you make a change, just have it open up in a separate document, write just that little note about the changes that you made, and use those peer reviews to improve your final writing research paper. All right, so that's the peer review process. The peer review assignments have already been assigned to everybody, so they are there and ready to go for you and turn it in. Any questions on this procedure before we move to correlations? All right. Okay, so what we're going to do today in terms of the research portion is correlation coefficients. And we talked about relations before. We talked about how relations can vary in systematic ways, where if one variable goes up, the other variable goes up. And we talked about positive and negative relations, but today we're going to talk about specifically the strength of relations. And we're going to highlight how these correlation coefficients, these numbers, can sometimes be used incorrectly to bias results or to present untruthful results. So before we get to that, just a reminder that we are talking with correlation, and correlation does not imply causation. It does not equal causation, but you will be surprised how quickly that flies out of your mind, especially if you see a correlation that makes sense to you, or that has a pretty, it seems obvious or intuitive causal link. So it's always good to remind yourself that correlation, many things are correlated that have in no chance, in no way could possibly be causal. So for example, there is, and this is from TylerVigan.com, they have a collection of spurious correlations. Apparently, the per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. So if you take a look at the national statistics year to year of how many people died in bed sheet tangling, and you take a look at the national statistics year to year of how much cheese has been consumed, well, it is a very tight correlation. Now, I don't think anybody here would argue that somehow consuming cheese makes you vulnerable to bed sheet tangling, or that somehow getting tangled in bed sheets would cause the surviving family members to just consume large amounts of cheese, right? I don't think anybody would make that argument, and yet the correlation is strong. So again, a good reminder that correlation does not imply causation. Same thing with divorce rates in Maine are actually correlated with the per capita consumption of margarine. So both of those have decreased over the last decade. And the list goes on. Age of Miss America, so the age of the Miss America winner, correlates with murders by steam, hot vapors, and hot objects. So when Miss America is older, when she's older, we have more murders by steam, hot vapors, and hot objects. When Miss America is younger, we have fewer murders by steam, hot vapors, and hot objects. And I don't think anybody would believe that people are sitting at home and watching Miss America and going, how old was that Miss America winner, 27? Give me my hair curler and I'm gonna go out and, nobody thinks that, right? But look at this correlation. Look at that. When one goes up, the other one goes up. One goes down, the other one goes down. And this is one of my favorites. I don't know if it's got to be updated for his recent output. But the number of people who drowned by falling into a pool and the films that Nicolas Cage appeared in are, again, highly correlated. And this one might have a more plausible connection. I don't know if people don't like Nicolas Cage films and just decide to end it. But anyways, it's correlated, but it doesn't imply causation. So always keep that in mind. But what we're going to be talking about today is when things are interpreted as just being correlated, they can still be interpreted incorrectly. But before we get to that, we need to identify or be clear on the concept of the correlation coefficient. So a correlation coefficient, it's a statistic. It's a number that tells how strong a relationship is between two variables. How strongly correlated are these two variables? So by example, all of these ones that I just showed you would have a very high correlation coefficient because they were all very correlated with each other. Now we do this because when you're describing a relationship between two variables, we as human beings will place it somewhere. It'll be placed somewhere on this continuum. So not even us as human beings, but it will be placed somewhere on this continuum. It's either going to go somewhere between having no relation with each other, changes in one variable are not associated with any change in the other variable, or it's going to have a perfect relation, where changes in one variable are exactly associated with changes in another variable. Chances are, though, it's going to be somewhere on this continuum, right? Weak relation, moderate relation, strong relation. And these have, again, describe how tightly the two variables vary together. So, for example, if this was the relation between increases in mood and increases in exercise, if there was no relation, this is what it would look like. So if this is, each dot is an individual person who exercises a certain amount and has a certain mood, right? That's what each of these dots represents, as an individual person. If this was the relationship between exercise and mood, then there would be no relation, because people who exercise little have low and high moods. People who exercise a lot have low and high moods. There's no relation between exercise and mood. That would be a no relationship relation. This would be a weak relation. You can see that it's still pretty spread out, but now it's tilted, where knowing exercise, how much a person exercises, tells you a little bit about what their mood is. It's going to elevate their mood a little bit, not a lot. Weak relation. And as those points get tighter, then you get stronger and stronger relations. So this would be a moderate relation. You can see the cloud of points are getting tighter. This would be a strong relation. Cloud of points are getting even tighter. And this would be the, you'll never find it in real psychology, perfect relation, where one predicts the other one perfectly. So in this case, there'd be a very strong relation between exercise and mood, where if you told somebody, oh, somebody came into my office today and they exercise 5 hours a week, they would be able to tell you, oh, they kind of have, a mood within this range of moods, right? They'll probably have a highly positive mood, but it's going to be within a range. That can happen. This almost never happens, where you can tell somebody, oh, somebody exercises 5 hours a day, and they'll tell you, oh, that person exactly has that level of positive mood, and no other level but that. It rarely ever happens. If you ever see this in data that you've collected, you probably entered it wrong. This is only seen in the correlation between height in inches and height in centimeters, speed in kilometers and speed in miles. It's usually an indication that somewhere along the line you've entered your data incorrectly. All right, but it's the maximum amount of relation. That's a perfect relation. Can't get more related than that. All right, so describing relationships. So your relationships can be positive, your relationships can be negative, and we've seen this before, so just real quickly, positive relation means that as one variable goes up, the other variable goes up, and as one variable goes down, the other variable goes down. So as exercise increases, so too does mood. As exercise decreases, so too does mood. That's a positive relation. The two variables go in the same direction. Negative relation is the opposite. In this case, the two variables go in opposite directions. As exercise increases, depression decreases. As depression increases, exercise decreases, right? If you're going to stay on this cloud of points, as one goes up, the other one has to go down to stay in those clouds of points. So we've seen that before, negative and positive relations. So why are we introducing an actual number for these relations rather than just relying on strong, weak, moderate correlations? Well, the reason that we're introducing this Pearson R number here is because when you're talking about strength of a relationship, you cannot help but bring into that judgment your own personal biases. And by figuring out a way to assign a number to it, we can remove those personal biases from the equation. So what I mean by that is, let's say that you collected this data, and you are a strong proponent of exercise and its effect on mood. And you're giving a talk, and you put this data up there, and you say, look, we collected how much people exercised, and we also gave them a mood scale. And as it turns out, the more exercise you have, the higher the mood. There's a positive relation here. And I believe this is a really strong relation. The two of them are strongly correlated. This is a strong relationship between the two variables. And a hand goes up in the back of the room, and this person has a personal agenda against exercise. They're anti-exercise. And they put up their hand and they go, you know what, I'm looking at your data, and it looks like a weak relation to me, right? Those points aren't too tight. That's kind of a weak relation. And you'd be standing there going, no, 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 look, they're very close, strong relation. And they would be saying, no, look how spread out they are, weak relation. And you could go back and forth like that, and nobody's going to convince anybody else. So we can't rely on our own human sort of interpretation of these. We need to outsource it. We need to make it objective. We need a procedure that can assign a number that everybody can agree on. Because when somebody says, this is a positive correlation, and the correlation coefficient is 0.7, nobody can put up their hand and say, I don't think it's 0.7, that looks like a 0.5 to me. Because it's math, it's statistics, it's a number, it's something everybody can agree on. So that's where we get this Pearson correlation coefficient. It is the statistic that measures the strength of these correlations. It can go anywhere from 0 to plus or minus 1. So it can go all the way from -1 to 0 to +1. And it has those two components. One is the sign, one is the strength. So the sign here tells you whether it's a positive relationship or a negative relationship. And then the number from 0 to 1 tells you how strong that relationship is. 0 is a completely weak relationship, no relationship. 1 is that perfect relationship. And depending where you are on the continuum, you'll be somewhere in between 0 and 1. So let's take a look at the R for positive relations. So in this case, we have no relation. There's your line to show that there is no relationship between exercise and mood. And if we were to calculate a correlation coefficient for this, correlation coefficient would be plus 0.02. Very close to 0, positive, but very close to 0, indicating an extremely weak correlation. If we increase the strength of the correlation, so now knowing something about exercise will predict something about mood, you can see that our correlation coefficient has gone up. It is now 0.23. And if we increase the strength of our relation once again, correlation coefficient has gone up corresponding to that. So now it's at 0.51. So if we get to that one that we thought was a strong relation, we find out that the correlation coefficient is 0.77. And nobody can argue with 0.77. You could argue all day about whether this is strong or weak when you're looking at it. But when you say, oh yeah, I've calculated the correlation coefficient between exercise and mood, and it's 0.77, even the anti-exercise person in the back is going to have to say, all right, it's 0.77. And your perfect relation, the absolute pinnacle of how related two variables can be, that has a correlation coefficient of 1. That's the upper limit. Can't go higher than 1. 1 is a perfect correlation. So that's a correlation coefficient for positive. You can also have correlation coefficients for negative relations. And for the negative relations, it's important to remember that correlation coefficients come in two components. One is the sign, one is the strength. So when you have a weak negative correlation, you'll have that negative sign. That indicates that it's negative. And then once again, the number indicates how strong it is. So one of the mistakes that people oftentimes make when they're learning about correlation coefficients is thinking that a minus 0.23 correlation is somehow weaker than a positive 0.05 correlation. The truth is the opposite. 0.23 is stronger than 0.05. Negative just indicates the direction. So make sure that you keep those separate. This minus doesn't mean that this is low. What it means is that it's in the negative direction, and then the 0.23 indicates that it's strong. It's just now strong in a negative direction. Make that relationship even stronger. Notice the number gets even more negative, closer to -1. And once again, that 0.51 indicates the strength. The negative indicates the direction. We increase the strength once again. We see that the correlation coefficient has now gotten even stronger. And then finally, perfect correlation. You'll never find it, but it leads to the maximum correlation coefficient, in this case, -1. Minus for a negative relation, 1 for the strongest relationship possible. All right, any questions so far? Okay, so before we get into interpreting these correlation coefficients, one last thing I want to point out is a little bit of math magic that you are going to encounter, because people use correlation coefficients a lot. That's one of the reasons I wanted to cover it. But this has to do with effect size. Now, effect size is a term for the general strength between two variables. And what statistics has done is it's made a whole bunch of measures for the strength between variables in certain situations. So for example, if you have two variables and they're measured on ordinal or interval scales, you can calculate a correlation coefficient, and that will give you the strength of the relationship between these two. Effect size is a general measure of the strength of the relationship. So it's a way of comparing relationships across different measures. So if you have like a Pearson correlation coefficient, and then somebody else runs an ANOVA, and then somebody else does a regression analysis, you can come up with effect sizes that will allow you to compare across those three different tests. It just so happens that somehow the effect size when you're doing correlations is calculated by just squaring the correlation. So the percent, and what this is, it's the percent of variance in one variable that is accounted for by the second variable. And that's a phrase you'll see as you continue to move through psychology. The percent of one variable that's accounted for by the other variable, the percent of variance that's accounted for by the second variable. And it just seems magical that if you square this number, you can get that percent. And because this is squared, it's going to go anywhere from 0, so 0 squared is 0, all the way up to +1 only. And that's because +1 squared is +1, -1 squared is +1. So all the negative correlations, when you square them to get their effect size, they're going to turn into these positive percentages. So what does this look like? What does this mean? Well, again, it's that idea, we've kind of seen this before, it's the idea of you have a certain amount of variability, and how much is knowing about one variable going to tell you about the scores on that other variable. That's what that reduction in variance is all about. And if you have a very weak, almost non-existent relationship between your variables, if we square that, we can see that knowing about exercise will be able to reduce this uncertainty by 0.04%, not even a full percent. So if somebody tells you how much an individual exercises, that's not going to tell you anything about how much, what their mood is like. In fact, it's only going to reduce it by 0.4%. So if you knew that somebody was had a low level of exercise, rather than having to guess between these two red lines, you could reduce your uncertainty and only guess in that green box. If you knew that somebody had a middle amount of exercise, instead of guessing between these two red lines, you could reduce that by a whole 0.04%. Right? So it's not helping you at all. It's reducing none of the uncertainty. As the relationship between the variable strengths, as the strength of the relationship increases, the amount of uncertainty increases as well that you can reduce. That reduction in uncertainty is increased. So if you have a correlation of 0.23, that gives us an effect size of about 5%. And what that means is that if you know the exercise amount, instead of having to deal with 100% of the uncertainty, you now only have to deal with 95% of the uncertainty. So it's told you a little bit. Knowing about exercise tells you a little bit about mood. Knowing about exercise takes the 100% of the uncertainty about mood and reduces 5% of it. So it's helpful, not very helpful. And the higher your effect size, the stronger your correlation, the more reduction in uncertainty you can get. So for this relationship here, slightly stronger with a correlation coefficient of 0.51, you square that, you get 26%. Knowing about exercise right now will reduce this uncertainty from 100% down to 74%. It'll take 26% of the uncertainty away when you know about exercise. So again, if you're trying to guess what the mood is and you have no information, 100% uncertainty. As soon as you know what the exercise level is, only 74% uncertainty, because you reduced uncertainty by 26%. And that's going to be for whatever amount of exercise you know, it'll reduce that uncertainty. Yep?
So the effect size is the 26%?
Yes. It's the 26%.
Okay.
And what was, oh yeah, so the 74% is how much uncertainty is left.
Okay.
The effect size is how much has it been reduced. All right, and so on and so forth. If we have a 77 correlation coefficient here, that leads to a 59% reduction in uncertainty, which means that telling you about the exercise will be able to reduce that uncertainty by 59%. So you're only dealing with a 41% window when you're trying to guess what that level of mood might be. And in the extreme example here, if you have a correlation coefficient of 1, you have an effect size of 100%. And in this case, if somebody tells you the amount of exercise that a person has, you can reduce the uncertainty in what their mood is by 100%. So with no information, if somebody said, what's the mood of a particular individual? You'd be like, I don't know, anywhere from down here all the way to up here. It could be anywhere in there. I have 100% uncertainty. If they then tell you, oh, well, they exercise two hours a week, you can say, oh, well, in that case, their mood is exactly right there. They got 50, score of 50 on the mood index. If they say, oh, no, they actually exercise 6 hours a week, you'd be like, oh, okay, exactly 60 on the mood index, and so on and so forth for any levels of exercise. So that would be the ultimate amount where you can predict one exactly. So again, the only examples where this ever occurs are on things like where one measure is converted into another measure directly. So if I was to say, what do you think the height is of Dr. Ladd? What's the height in inches of Dr. Ladd? And you're like, I have no idea. Give me some information. And if I said, well, he's 176 centimeters, well, you can perfectly predict how many inches he is because you just Google it on your phone and do the conversion. That's the only time this ever really happens. But this is kind of like the ultimate holy grail of what you're trying to attain. All right, so any questions on effect sizes or correlation coefficients in general before we take a look at how to interpret them? Okay, so this is going to be very important for critical thinking because we live in a world where people love to throw around numbers. Numbers have power, but numbers can hide the truth a lot, especially if people use them in the wrong way. So we want to make sure that when you leave IUSB, you know how to deal with all of these measures that we've been introducing. So we're going to take a look at issues when you're interpreting the correlation coefficient. So if somebody tells you, oh, I did this study and the correlation coefficient is 0.17, we're going to give you the skills right now to interpret that correctly, because as you'll see, there can be ways to lie with correlation coefficients that you need to keep in mind. All right, so issue number one. Issue number one, very important issue, you need to consider restriction of range. And this is especially important when you find a low correlation coefficient. So if somebody mentions that there is, they've done this study and there's a low correlation between these two variables, a little red flag should, raise in your mind, a little siren should go off, and you should say, let me see your range of your data. Why is that? All right, so let's take a look at this hypothetical data here. There's a positive correlation between funding and academic performance. That's why scholarships and financial aid exists, right? So the more funding you have, the better your academic performance. And let's say that I went out and I interviewed, 1,000 IUSB students, and I said, what's your GPA and how much funding do you get per year? And this is the data that I got. If I took this to, let's say, the governor of Indiana, and I told him, I go, look, I've done this study, and I've talked to all these IUSB students, and I've asked them how much funding do they get, and I've asked them what's their academic performance, and look, the two of them are correlated. And I think that we should do a study to see if academic funding actually causes performance, because they're correlated, so maybe there's a causal connection there, right? That's my data. Somebody else might go and talk to the exact same population of students, but if they don't get the range that I did, if on the other hand, let's say that they only talk to students that had low amounts of funding, let's say they go to one particular neighborhood where it's lower socioeconomic neighborhood, and they talk to the students, but only the ones that have lower funding. Notice that these dots, these dots here are the same students I talked to, right? It's just that the second study didn't talk to all of these students. So because of that, they have a restriction of range. Same situation, same population, should have the same result, but because there's not as much of a range, when you fit a correlation coefficient to that, it's not a strong relation. It actually goes way down to almost no relationship whatsoever. So this occasionally happens, and you will hear people argue back and forth about how, in this case, if those two people were in the same room, I would be sitting there going, well, my studies have shown that funding is highly correlated with academic performance. And they would say, well, my studies show that it's not highly correlated. And I would say, well, I talked to students here at IUSB. And they would say, well, I talked to students here at IUSB. And you can go back and forth and not understand why you're not agreeing until you remember that restriction of range and realize that, yeah, they talked to the sample, but they didn't have a large range. So they weren't able to pick up the actual truth of what's going on because of that restriction of range. So if you see that low correlation and it doesn't make sense, think about, was there a restriction of range in the data that they collected? All right, issue number two. Issue number two is the curvilinear relationship. And this is why it is always good to take a look at a graph, a scatter plot of the actual data, not just a correlation, the fitted correlation line. And this is an issue because the correlation coefficient, the Pearson correlation coefficient, only describes linear relationships. It only describes relationships that can be best fit with a straight line. So this relationship between funding and academic performance can be best fit with a straight line. That's a pretty good line to draw through these points. Sure, it misses some points at the top, it misses some points on the bottom, but in general, it's close to most of these points. That's a linear relationship. Curvilinear relationships don't work the same. So here we've seen this example before, music complexity and enjoyment This is a curvilinear relationship because music that has low complexity typically is not enjoyed by individuals. Music that has high complexity, typically not enjoyed by individuals. Music somewhere in the middle, this is the stuff that is pop music, mainstream music, highly enjoyable music by most people. This is a perfect relationship. This is as strong a relationship as you can get. But if you reported the Pearson correlation coefficient to this, you would get a correlation of 0, indicating no effect. So if you were to only rely on the correlation coefficient, you could say that there is no relationship between music complexity and enjoyment. My Pearson correlation coefficient is 0. It's 0 because this is curvilinear, and you're trying to fit a straight line to a curved relationship. Can't do it. So if you read this, again, you have to do your critical thinking and say, look, that correlation coefficient is low. It makes sense that music complexity and enjoyment should be related somehow. Maybe this person is fitting a straight line to a curvilinear relationship, and that's why they're getting such a low correlation. All right, so those are two issues, curvilinear relationships and restriction of range that were in your textbook. This last one here, I'm going to let you know about because this actually happened to a student here at IUSB that was working on their advanced lab. So I will bring it up here as well. And this kind of ties back into Homer Simpson at the beginning. It's actually known as the Simpsons paradox. Not named after Homer Simpson, but named after another Simpson. And this is when correlations can actually reverse when groups are combined. And it is a paradox because if you, for example, look at undergrads and measure their relationship on two variables, they might have a positive relationship. If you look at graduate students and measure their relationship on the same two variables, they may have a positive relationship. You combine those two groups. Surely, if it's positive for one of the groups, positive for the other group, when you combine the two groups, it should still be a positive relationship. Those relationships can reverse, and that's the Simpsons paradox. So be, again, very wary of this. And this one will actually happen at all strengths of correlations. So let's take a look at this, and I'll give you some hypothetical data where this could happen. So here we have percentage of scholarships on the x-axis, and here we have the grade level for individuals, and we'll code the grades as just continuing numerically. So, you know, if you go to the final grade in high school, you're in grade 12, and then your first year here, let's call it grade 13, your second year here, grade 14, just so we can have them on that interval scale. Actually, I guess that would be a ratio scale because we got that absolute 0. Anyways, if you took a look at different scholarship opportunities, you'll notice that they tend to increase as grade level increases, right? So it's very important to make sure that students in high school can actually still afford to go to high school. So there will be more percentage of students, and this is hypothetical data, but in general, there will be higher percentage of students getting scholarships in grade 9 than there are students getting scholarships in grade 5, than there are students getting scholarships in grade 1, some sort of financial aid. So this is a positive relation. Look how positive. It's 0.99. It's about as high as you can get. Positive relationship between grade level and scholarships. As grade level increases, so too does the percent of scholarships. That's group number 1. Group number 2 is adults. So we had children in elementary school, and now we have adults going through to university, master's, PhD programs. And this is also very typical, that the amount of scholarships that you get in your undergraduate university is less than you will get in a master's program. So when you're applying for master's programs, take a look at their scholarship opportunities. There are more than you will have access to right now. And the same goes for PhDs. PhDs have higher levels of scholarships than master's. Master's is higher than undergrad. And again, if you fit the correlation to this relationship between grade level and scholarships, we get, once again, an extremely high correlation. So we got high correlation for children, high correlation for adults, positive correlation for children, positive correlation for adults. And if you took this data and said, well, let's just combine all of this into one big data set and calculate the correlation coefficient, high for children, high for adults, calculate the combined correlation coefficient, you get a negative correlation. Negative when you combine two highly positive correlations, and that's the Simpson's paradox. And what's happening here is that when you take a look at the graph of them, in each group, the correlation is positive. But because it drops from elementary school to university levels, because the amount of scholarships drop between those two, the overall pattern is actually negative. So within groups, highly positive correlation. Overall pattern, highly negative correlation, and that is the Simpson's paradox. And again, the student that was here working on their advanced lab did not know what was going on because when she looked at the individual groups, high correlation. When she aggregated all her data, where did her correlation go? She was a victim of the Simpson's paradox. And actually, that's when I first learned about it as well. All right, any questions about correlations? Okay, so I was going to go over inferential statistics, but we're not going to have time for that. We'll do that when we come back. But just to place it in your mind, just to make sure that we kind of plant that seed about what inferential statistics is all about, I'm going to bring up the results that we have, because we're going to write about the results section. We're going to write the results section when we come back from fall break. We're going to do it in class. We're going to talk about the procedure next time we meet, but I will literally stand here at the front of the class with the Word document open, and I will act like a secretary taking dictation, and we'll write it all together. I'll give you guidance and provide a structure for that. But one of the things that we need to do for the results section is you report the stats and not the numbers. You report the inferential statistics and not the actual numbers that you, and not a description of the numbers. I'm doing a bad job at explaining this. This is what I mean. We are going to report the effect of group size on the correct items, right? So if you recall, this is data from our experiment. The blue bars are how many of the correct items did people recall. Higher bars mean better recollection. The red bars indicate how many false items were recalled. So once again, higher bars means higher number of false items were recalled. And then we have singles, we have pairs, and we have groups of 3. And this is the data here. Now, if we were to report the numbers for the correct items, we would say, if we didn't have statistics, we would say, oh, the single individuals recalled fewer correct numbers than the pairs, and the pairs recalled fewer correct numbers than the groups of 3. That's what we would write in the results. And as it so happens, that is exactly what inferential statistics tells us. That this group here, singles, did actually recall less than groups, and they did actually recall fewer than groups of 3. So we would, in essence, be reporting the statistics. We're reporting what the statistics indicated. And that's going to be the most important when we take a look at these critical values. Because again, if we take a look at the numbers, right, 42% false memories for singles. What do we got here? 40% false memories for pairs. 35% false memories for groups of 3. If we were to report this without the statistics, I, as a human being, would say false memories were highest for the singles, in the middle for the pairs, and false memories were lowest for the groups of 3. That's how I would interpret this as a human being. That's why we need statistics, because statistics took into account the difference in size here, but also the difference in reliability. Remember those girls playing basketball, 200 times. And what statistics has said is that this group here, singles, had the same amount of false memories as pairs did. And they had the same amount of false memories as groups of three did. And when we write up our results section, we are going to write up the statistics. So when it comes to talking about false memories in singles, pairs, and triples, we will actually write singles showed, had the same amount of false memories as pairs did, and pairs had the same amount of false memories as groups of three did. And we'll report the numbers because we're writing the results section. But when we talk about it in that results section, we report the statistics, the statistical conclusions, not the way it looks to us as human beings. So that's just an important thing to keep in mind. I want to plant that seed right now because there is always resistance to say things like, well, there was a difference, but the difference wasn't. No, there is no difference. If stats says there's no difference, make it simple for the reader. Say, there was no difference. If stats says that there is a difference, make it simple for the reader. Say, yes, there is a difference. And we're going to be doing all that when we write the results section together. All right, so that is it for today. Any final questions or comments before we wrap it up? Okay, so that is what I wanted to cover for today. So don't come here on Tuesday. Enjoy your fall break. And I will see you all in a week. And again, start looking for your substitute articles for the resubmissions. Make sure that you get those early enough so that I can take a look at them and give you your 3 shots. But other than that, I am done for today.